Okay, today we're looking at section 8.8, which is the last section of the chapter. And what we're doing today is we're going to be factoring higher degree polynomials. Okay, so first thing, let's get started. Let's try multiplying these two. And once again, I can't spell multiply. I forgot to change it from this last one. So if I use the box method for this one, I have an x squared minus 4x and an 8 up here. I have an x and a negative 4. If I multiply, I'd get an x to the third minus 4x squared plus 8x and a negative 4x squared and negative 16x and a negative 32. And if I were to combine like terms, my final answer would be x to the third minus 8x squared minus 8x minus 32. Okay, so that's one of the ones we're going to be factoring. We're going to be factoring things with 4 terms today. And then the other thing I just wanted to see is that what happens if I have a number out front, a constant out front. So if I distribute, I get a 3x plus 8. Now I got to take that whole thing times x minus 5. So if I just FOILed that, I would get 3x squared minus 15x plus 8x minus 40. So my final answer would be sorry, I screwed up back here. This should have been a 24. So this would have changed, sorry, let me gather my thoughts here. So I'd have a 3x squared if I FOIL. I'd have a negative 15x. This would be a 24x, and this would be a negative 120. I apologize for that. So my final answer would be 3x squared plus 9x minus 120. So my question is, where does this 3 show up that we had out here to start with? That 3 shows up as a common factor of those 3 terms. Okay, so 3 was a common factor. So a couple things we're going to be doing it today. We're going to be factoring out common terms or a common factor, and then factoring you with 4 terms. So you might see something like this. So how are we going to do this? Well, here's how we're going to do it. Each term gets a box, and then we simply do this. Look for the greatest common factor here. The greatest common factor of those two would be a 4x squared. The greatest common factor of these two is a 5. The greatest common factor of these two is a 2x. The greatest common factor of these two is a 1. If you checked all your boxes back multiplying, you would find that this does work. So our factors of this polynomial would be a 4x squared plus 5 times a 2x plus 8, 1. Okay, so if I did it on this next one, again, fill in your boxes. So if I look here, I know that I've got a 9x squared as the common factor. If I looked here, I'd have a 2, but since this 8 is a negative, I'm going to factor it out as a negative 2. If I look here, I would see that I've got a 4 and an x common. If I looked here, I could see that I have a 3 common, but since the 27 is negative, I'm going to make it a negative 27, or negative 3, excuse me. So my two factors would be 4x minus 3 times 8, 9x squared minus 2. Okay, next one. If we try this one, the first thing we're going to do on this one, we are going to see that we have a common factor in each one of those terms. So our common factor for this one, we know that 2 goes into them. We know that 4 does. Greatest common factor would be a 4, and we can see that there is an x that is common between all these terms, so we'd factor out a 4x. What would I be left with? I'd have 8x to the third plus a 2x squared plus a 12x and then plus 3. So what goes in my boxes now? 8x to the third, a 2x squared, a 12x, and a 3. So now we're looking at common factors this way again, and hopefully we can see that we got 2x squared that's common. Factor this way would be a 3. If I do factors this way, I got a 4 and an x. Factors here would be a 1. So what are my complete factorization would then be a 4x times a 4x minus 1 times 2x squared plus 3. Okay, 2 more slides. So if we look at this one, similar to the last one, our common factor here would be a 5p. So if I factor out 5p, I'd be left with 6p to the third minus 9p squared minus 2p plus 3. Okay, so if I put those back in, I'd have 6p to the third minus 9p squared minus 2p plus 3. And then look at common factors. Here I can see that I'd have a 3p squared. Here I'd have a 1. And since this is a negative 2, I'd make it a negative 1. If I look at factors this way, you can see I've got a 2 and a p. And if I look at factors this way, I would just have a negative 3. And if you checked your boxes back, you would find that we have the correct factorization. So my complete factorization would be 5p times 2p minus 3 times a 3p squared minus 1. Okay, one last one I want you to try on your own, and then come back and we'll see how we did. Okay, first thing you should have checked to see if there was any common factors for all these, and you should have found that there was not. So all we do, we plug in our numbers, and we then look for common factors. So common factor of a 64 and a 40, I would say the biggest thing that goes into those is an 8m squared. Greatest common factor here would be a 3, but since 24 is negative, it should be a negative 3. And then common factor here, out of a 64 and a 24, 64 and 24, greatest common factor again would be an 8 and an m. Okay, and then the greatest common factor here would be a negative 5. So if you checked your boxes, all your boxes work. And so your factors would be 8m squared minus 3 times then 8m minus 5. Okay, I know that can be kind of confusing, but hopefully it makes a little bit of sense, and make sure you come with your questions tomorrow. Okay, that is a wrap.